Hello, everybody. Today in geometry, we're going to be taking some notes over predicting the effect of transformations. This is our 1.K2.3 standard and actually our last standard of this unit. So before we get into that, let's talk about size, orientation, and location. These are going to be the things that we refer to when we're talking about the effect of a transformation. So first, we want to specify, has the size changed? Okay, and if it's not super obvious, which it won't always be, we can, compare some side lengths or look at the coordinates and see if those have changed. That should let us know if the size has changed. For orientation, the orientation is the order of the vertices. So if we're looking clockwise around a shape, are the vertices going in that same order? So are the vertices in the same order? Okay, for example, we could have a little triangle with vertices A, B, and C. We want to know if we reflect it, would they be in that same order? Make sure we go the same way. So if you're looking clockwise the first time, make sure you go clockwise after it has been transformed as well. And the last thing is the location of a figure. And the best way to refer to a location of a figure is using quadrants. So has the quadrant changed? And we will review what those quadrants are in just a few minutes. But first, let's go ahead and look at each of these transformations, translation, rotation, reflection, and dilation, and determine if the size, orientation, and location changes. Luckily, these rules are pretty consistent. No matter what we're dealing with. So let's take a look down here at, let's start with size. Okay, I want you to take a second and think about which of these preserves the size, which means stays the same, and which ones change the size. So in each box, we're going to write preserve or change. Okay, take a minute to do that. Awesome. Okay, so if we're thinking about a size change, we know that the only thing that changes the size is going to be a dilation. So right here, we'll say change. And for translation, our size does not change, so we'll say preserve, as well as rotation and reflection. I'm going to be lazy and duplicate. Awesome. So the only transformation that changes a size is a dilation. Okay, what about orientation? Take a second to think about that and really you may need to draw yourself some examples. Maybe refer back to our ABC example over here. Reflect it, rotate it, translate it. Okay, you try. Okay, similarly to size, only one of our transformations changes the orientation, and that is actually a reflection. Okay, when we reflect, the order of the vertices do change. All the others stay the same, so we will say preserve. For translation, rotation, and dilation, those vertices do stay in the same order for everything but reflection. So reflections cause that flip of the vertices. And I guess I can show you over here. If we reflect my triangle ABC, A is still up here. My C was my right angle here. And then this was B. So looking clockwise, originally I went from A to B. On my reflection, it now goes from A to C. So we can see that the orientation, the order of the vertices clockwise, has changed from A to B to C, now to A to C to B, and we'll go ahead and label these prime. If you want to draw this example, you can sketch this out on your paper, but you definitely don't have to if that makes sense to you. Okay, lastly, let's talk about location. Location is one of those tricky ones. There are some trickies, and you may want to put sometimes on some of these. So let's say if it preserves or changes. And remember, when we're talking about location, we want to refer to the quadrant in which it's in. So yes, some of these things change it a little bit, but does it move it out of the quadrant? That's what we want to think about. Okay, give me your best guess. Okay, first let's talk about translation. Obviously, a translation is a change in the location of a shape. Sometimes it may move out of the quadrant. So here, let's put sometimes. This is a reminder for us to just always double check. This is one that we want to always double check using some sort of visual or maybe even using a graph. Okay, so that one is a little bit special. I'll put a little star by it. A rotation, again, typically does change the quadrant, and that happens when our rotation is about the origin. So about 0, 0. Of course, if we rotate a shape around itself, it's not going to change that location, but it does typically change because a lot of the times we are rotating around the origin. That's when we turn our paper completely to do so. Okay, a reflection does typically change the location. Okay, if we're flipping over the x-axis, it'll switch. Y-axis, it'll switch. Even our funky reflections like y equals x, there's typically some changes that go on there. And then dilation. This is similar to our rotation rule in the fact that this only applies to when it's about the origin. About 0, 0. This one is actually preserved. Of course, dilation does change the location, but it will not move out of a quadrant if we are dilating to or from the origin. So if we dilate from a half, that shape is only going to move closer to the origin and not out of that quadrant. Same goes for if it's a bigger dilation. If it is an enlargement, it'll move further away from the origin, but stay in that same quadrant. So have to be careful there as well. That is the only one that is typically preserved. But of course, this only works about the origin. If we're dilating from another random point, then we'll definitely want to double check that by performing that dilation on the graph. Okay, let's go ahead and look at some examples. So at the bottom of our page, we have two examples here. One of them has a graph and the other one does not. So let's start with the graph example first. We are given this triangle T and K, and we are told to predict the effect of the following transformations on T and K. So we have a 180 rotation around the origin, and then we have a reflection over the y-axis. So because we're predicting, we're going to try not to, perform these on the graph, but it is here to help us if we need it. So first, a rotation around the origin. Obviously, this shape is going to go 2 quadrants, so it is now going to be here. And then from there, we are doing a reflection over the y-axis. So as a really quick sketch, our shape would be right about here. Okay, this would be our K prime point. This would be our N prime point, and this would be T prime. Okay, and then we're reflecting over the y-axis. So here. Okay, so this is where it ends up. We want to know, does the size change? Does the orientation change? And where is the new location of the shape? So obviously, we can just do that really quickly without having to draw it in. There's our 180 rotation, then reflect over the y-axis. So did my size change? No, it's going to stay the same. Now, orientation is the order of the vertices around. So I'm going to go clockwise. Originally, it was T to K to N. Now it's T to N to K. So that did change. So we can say change. And location. Originally it was in quadrant 2. Let's go ahead and label our quadrants just so we have those. Quadrant 1 is the top right, my positive. Quadrant 2, top left. Quadrant 3, bottom left. And then Q4, bottom right. Okay, make sure we have those labeled. Okay, so originally it was in quadrant 2. Now it is in, very good, quadrant 3. So our new location is quadrant 3. And that's all there is to it. Okay, the second example, we're not given a shape. We are told that the shape is in quadrant 2. Okay, this is more like what we're going to be seeing on our assessments. We're going to be given the location of a figure and then predicting the size, orientation, and location changes. Okay, so quadrant 2, that's similar to this one. It's starting out here in quadrant 2. We don't know exactly where, and it doesn't really matter. We're just going to perform these transformations on it. So dilation of a scale factor 3/2 from the origin. No matter where that is, it's going to push it further into quadrant 2. So it does not matter. When we multiply by a scale factor that's bigger than 1, it's going to move further from the origin, but not change quadrants. So now we have this little green star here. And lastly is a 90-degree counterclockwise rotation. So that is going to take my star and move it down here. Okay, counterclockwise is this way. So finally, my shape is going to be somewhere in quadrant 3. So this example, very similar to the last. New location is quadrant 3. Did my size change? Yes, it did. It changed. And how about my orientation? No, it did not, because we did not have a reflection. Remember, up here we said reflection was the only transformation that causes an orientation change. So neither of these were reflection, meaning my orientation stays the same. All right, and that's all there is to it. Okay, I'll scroll out so you can see everything all at once. If you have any questions, ask your facilitator. If not, have a great day.